Hello, I assume you're watching this because you need to review very quickly. With that being said, the amount covered here is definitely not sufficient for proper studying. I would suggest looking at your syllabus or whatever you have and reference that while you follow along with this. This is just a very short video. I will probably expand on it in the future. Good luck with your testing. I hope you pass. So there are three main types of studies. The first one is correlational studies, which look at the relationship between two variables. But what's important to remember is that you cannot find causation here because of the fact that there is no manipulation. The next is an observational study, which can be done in the lab or in nature, and you just observe what others are doing without interfering. What's good about the lab is that you have control of the situation, but it really doesn't feel as natural. And what's good about nature is that it's incredibly natural. However, if something is to somehow go wrong, you have no control over that. Because there's no manipulation here, we cannot find causation. The next thing we should cover is the operational definition. With all these studies, we are looking at the relationships between two things. For example, what's the relationship between living in a neighborhood close to the interstate and how much you socialize with others? See, we need to have a definition for what socializing is. Could socializing be talking online, talking to people in person? Would this be recreational only or going to work? We need a definition for neighborhood. Is this 4 city blocks? Is this a mile? Is this 2 miles? We need definitions for all of those things because the most important thing about a study is that it can be repeated and standardized. Next, we have experimental studies, which show causation through the use of a manipulation, and we do this by using the dependent and independent variables. The independent variable shows what can be manipulated. The dependent variable shows what is measured. We can remember this by saying dependent is equal to the data. For example, an independent variable could include your handedness or the type of test you take, for example, multiple choice or fill in the blank. A dependent variable would include something like your GPA or how well you perform on a task. So with an experimental study, you can have two types of independent variables. You can have a true independent variable, which means it can be applied randomly to anybody, or we may have a quasi-independent variable, which is not randomly assigned because it's often something you cannot change. For example, your handedness or your eye color or where you're from. Experimental studies can be more complex or simple. The most simple type of study you can have is one that has one dependent variable measuring one outcome and one independent variable with two levels. For example, taking a drug versus no drug at all. We can increase the complexity by adding more conditions to the independent variable. For example, taking a pill, taking an injection, and then taking a placebo or taking nothing at all. We can also make this more complex by adding multiple independent variables. For example, an asynchronous test versus a synchronous test paired with multiple choice and fill in the blank. We can also increase the amount of dependent variables we want. We can look at how sleep affects stress, how it affects memory, and how it affects performance. With these conditions, there are generally two ways to implement them. There's the between subjects design, which means that each condition of the independent variable is carried out by a different group. For example, one group could drink coffee and the other may not. In using a within subjects design, participants perform in all conditions of the independent variable. In an experiment, there can be a lot of bias, so to curb this, we can use a single blind where participants don't know which group they're in, or a double blind in which neither the participant or the researcher knows which group they're in. Even by taking measures like these, there are still opportunities for error, for example, confounding variables. A confounding variable is a variable which is unaccounted for or unknown, which may affect the results of the data. Another type of bias is sampling bias, and there are many types of sampling bias. One includes non-response bias, in which only specific people choose to participate in your study, which can affect the results. For example, if you're doing a study on the effects of caffeine, maybe only coffee drinkers will want to participate, which is problematic because we will not see the results on people who don't normally drink caffeine. Another type of sampling bias is survivorship bias, in which data only focuses on existing observations and doesn't focus on past observations that may have existed but no longer do. An example of this would be looking at wrecked planes. If a plane can make it back to the hangar, that means it's in good enough shape to at least move somewhat. However, in this, we are not looking at planes that have been destroyed completely. In this, we are neglecting a significant portion of the population. One more example of sampling bias is selection bias, in which a certain group has a higher chance of being represented over another when collecting data. For example, if you're trying to gauge an accurate number of Democrats and Republicans in the country, it will be more likely that you will find Democrats in cities and that you'll find Republicans in rural areas. So to avoid bias, you have to make sure that you're surveying in both of those types of areas.